Welcome to the Descalated.
Hey everybody, and welcome to another Descalated. This is the Daylight Savings Edition. You lost an hour, so why don't you spend an extra hour watching a PCB milling machine mill? That's what we're going to be doing tonight. We use the Othermill at work at Adafruit, but I wanted to have a backup spare machine because it's always good to have two of everything, like one backup. And since I was going to set it up anyways, I thought, like, let's just bring it home, set it up here, and mill out a PCB. This is going to be the PCB I designed yesterday. It's the pretty simple relay feather wing tester, a good candidate for a first mill because there's not a lot going on. So let's go to the computer and check out the PCB, and then we will go to the other mill, which is over on the desk over there, and check that out. Everything okay? All good? Computer? Okay. So this is the board I'm going to mill out. Pretty simple, not a lot going on here. Basically just have signal traces to everything, and then a little piezo and LED to indicate when it's tested. It's a simple tester, but it's standardized for the way all of our testers work, that you press the board down, automatically detects when you would press the board onto the PCB, hits all the pogo pins, does a test, and then beeps and blinks an LED. So really simple, pretty much foolproof way of testing all the boards. So we're going to use the other machine, an Othermill. So this is a little mill that you can get. We sell it at Adafruit, but it's actually made by friends as well, so it's cool. It's assembled in San Francisco, and it's kind of like a small milling machine. It's a very powerful, very, very precise. It can definitely do PCBs. It's one of the things that it's really good at. It has built-in stuff here. You can see I did a little report with them about how we design our testers with an other machine. But you can also cut all sorts of plastics, some soft metals, brass, wood, molding wax, so you can use it to design something, and then you would lost wax cast it. And they have software for Windows now, which is cool. So let's start that up. And this is what the software looks like. It's beta. The Mac software is actually a little bit more advanced. It has a really nice rendering, but this does work. So I've already loaded in a 1/32 inch flat end mill. That's the larger of the end mills. A 1/64 takes a long time. It's good for precision, but the design I showed you, it's pretty basic. You can use a large mill and it'll be just fine. And then let's open a file, and we'll tell it we want to open this file. And it will automatically render for you the tool path, so you can see where it's going to etch out all the components. And you can change different views, so it's kind of nice. There's a top view, and let's see, advanced trace depth, that's fine. Trace clearance, that's fine. It's just going to take 37 minutes to mill. It does 2 passes, which is why it takes a little bit longer. It would be really neat eventually if I could force it to only do a single pass, but I think for quality and safety, because you want to really remove all the materials so you don't have shorts, they only let you do the default, which is 2 passes, or at least I couldn't figure out. There's a bit breaker, but which shows you all the commands that it's sending, but this version of the software doesn't let you actually twiddle those settings. But what's neat is it's going to, let's do the ISO view. it's going to do the outline last. So it's the outline, so it outlines the board for you. So it's kind of nice if you want a weird shape. All the holes, and this is like drilled down, and then the traces. And yeah, so you'll do traces first, then holes, and then outline. I think that's the order. And so when it's done, we'll be able to pop it right out. So that's pretty much it. So I'm going to go now to the other machine and load in the material. So you can just go to the front cam, and I'll just. So this is, you just remove this, and I've already loaded a tool in. But if you were, oh, 1 second, I have to put this in loading mode. Hold on, let me tell it to machine loading. This is just telling it, hey, move the milling surface forwards. This is a very, 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 very flat milled surface. You can tell it actually mills it on its own. That's how it knows it's like, it will be perfectly flat with orientation to this bar. And then I want a PCB, so I'm going to recycle this PCB. Basically, it's an FR1. It's not fiberglass, it's paper phenolic, which makes it a lot cleaner and easier to mill. And it's single-sided. You can do double-sided boards, but I don't seem to ever need to do double-sided. If I do need a trace, I'll usually just put a jumper. And then you need some double-sided tape. And you can do some more advanced fixturing, but you know what? Like, this works pretty well. And then you just lay down a couple pieces of the double-sided. Don't overlap them. You want them to be, you know, one after the other. And you just want to make sure that they're nice and flat, because this thickness does add a little bit. It's actually good. It adds just a little bit of thickness so that when it drills through, you know, you have to poke it a little bit, but it doesn't hit the bed, which is kind of nice. And then I don't need a lot of precision here again, because I don't have to align it. I just basically put the PCB as square to the corner as possible, and then I rub it down soft. Just make sure it's in there all good. And then you have to close this up, and when you close it, there's actually a reed sensor back here. Yeah, there's a reed sensor like embedded into this plastic, and it detects this little magnet, so it will automatically turn off if the sides panels or the back panel come off, which I don't expect they will, but it's kind of nice. It has a little protection so you can't stick your fingers in. And then I'm not going to change the tool out. You know, the tool I'm pretty happy with. It's even zeroed. So now I'm going to go back to the computer and get this stuff going. So do you want to go to the compy, or I'll just press start, and we'll just do start. So start milling. Okay, milling will pause and prompt you to change the tool as necessary. Well, I'm not going to change the tool. I'm probably going to do this one tool. And that's pretty much it. It's just going to mill out that PCB. So we're going to just hang out here for about 35 minutes. Do you want to show the computer? Because the computer actually has the, we could flip between it, or I don't know, just because it has this cool software showing it. Yeah, so in the software you can see there's a little rendering of the tool as it cuts out all of the traces. That's kind of neat. Okay, that's all I wanted to show. And yeah, it's control over USB. So I set this up earlier today. I plugged in the power supply. It's got like this 200-watt power supply because it has these gigantic stepper motors and the spindle motor. And then it just connects over USB, and it's actually a TDG device. So if you go to Device Manager, it says TDG version 2 control and data channel. So it's probably, you know, some microcontroller that's running TDG, a G-code interpreter. And then you can see, here's the commands that are being sent, they're in JSON format, but then once in a while you'll see it change to G-code. So the blue is G-code, and then the black text is JSON data. So you can actually, if you wanted to, I guess, send it raw G-code commands. You risk damaging the machine, of course. It'll like drill into the base plate, or it could like slam into the sides. But the software kind of does everything for you. Okay, so I can answer questions because we're just gonna be hanging out.
Yeah, the question is, and I'll try to have me around. What's the largest thing you've ever milled in the Othermill?
I've only done PCBs actually. I haven't done any other materials because I just like electronics. But I've milled like a 4x5 PCB. Mm-hmm. So you know that's the default size that you get when you get the PCBs. They're 4x5, and I've basically used a full one.
Yeah. All right, folks can ask questions if you want to in the chat, but we'll hang out here.
Just gonna hang out.
I'm gonna get
You have two of these.
Yeah, I'll get a photo of this while it's all happening. It's hard to tell which device goes to what now. What kind of resources are out there for designing custom PCBs?
For designing what?
Custom PCBs.
Design and testing, or designing testing?
Designing custom PCBs.
Oh, custom PCBs. I like to use EagleCAD, but you can also use Fritzing. You can use like PCB 123. You can use like Scheme-It. There's so many tools out there. A lot of them are free these days, which is really nice. There's great YouTube videos, and Instructables has a lot of tutorials as well on designing your own PCBs. It's not really as hard as you might think. It's, you can use OshPark and get PCBs made. If you don't, this is a $2,000 machine. We use it a lot, so it's worth it. But if you're only making a couple of PCBs, sending them out to OshPark, you get them a week later is pretty sweet. Used to be you have to spend like $200 to get prototype PCBs, and they didn't even come with mask. So this is kind of nice. I don't think Lostfet really likes the sound too. I think he's a gaddy.
Think he likes the sound?
Yeah.
Try to get up. Okay. Next up, does this mill out the board outline as well, or do you need something separately like a Dremel?
It's also going to outline and do the mill outline. So I can't do it now, but you can see like this outline here. At the very end, it will cut the outline of the PCB for you. So it's really good if you have like custom weird PCB shapes. That's sometimes PCB houses won't cut weird shapes for you. So it's one of the times where having your own mill is actually really beneficial. You have to have interlocking shapes, or like triangles, or hexagons, or circles. Beep, beep, beep.
Okay. Next up, how is it hard to calibrate the Othermill?
No, you don't really have to calibrate it at all. I mean, when you put in a tool, it will home. But other than that, there's really, it uses stepper motors. So there's not really, other than homing and the tool height. I think if you really use this a ton, maybe once in a while you'll have to reface the platform, but I've never had to do it. Mostly you just have to get new mills. Like your mills get dull, so you'll have to get a new end mill, but that's normal. Whatever you do, you always have to get new tool bits.
Okay. some folks are asking for a close-up on this, so I'm going to try to do it.
Yeah, go back to the...
Yeah, and then I'm also going to get this camera on you.
Oh, sorry, I'm like...
You're slacking.
I'm slouching.
Slouching and
I'm
slacking.
chilling.
Okay, so I'm going to move the camera closer.
Okay. Yeah.
Just tell me...
Okay. Close. That's pretty good. You want to tilt a little bit counterclockwise? Okay, stop. That's pretty good.
Okay.
And you can also zoom in after this.
Okay.
All right. Hopefully people will be satisfied with this level of zoom in.
Yeah, that'll be fine.
That's pretty good zoom in.
Oh, I'll go back to the...
No, this is cool. I mean, I think we should just keep
Yes,
this.
no, this is fine.
Well,
Next up. The next question was, what's up with the flip-flops in the cell phone? Well, I can answer that. Lady Ada wears flip-flops, and she doesn't own a cell phone.
I actually am not. I'm not wearing shoes at all right
Yeah.
now because I'm at home. But
Yeah.
in the office, I don't like wearing heavy shoes, so I often wear sandals. It's getting to be
Yeah.
sandal weather, so I'm kind of excited.
Next up. But you did build a cell phone jammer called the Wave Bubble.
I
People
did.
can Google it. Wave
Yes,
Bubble.
that's one of my first projects. I'm actually thinking it's kind of the 10-year anniversary. Maybe it's time for me to revisit and revise that project because I think I can build one now that's like featherweight sized, really
Yeah.
like a 2" by 1" cell phone jammer.
Okay.
So that'd be fun.
Next up, where do you recommend for purchasing the FR1 material for the best value?
You know, actually, Othermill sells it at a very good price, and you can get FR1 a lot of places, but the one they have, and they kind of don't share the source for it. It mills very nicely. It chips away the material without cracking. So, honestly, getting it from Othermill is pretty cheap. I think it's only a couple bucks for a 25 pack or something, and it's definitely worth it. It's like maybe a couple dollars each. You can buy FR1 from like Hobby PCB electronic sites like MPJA or Jameco, I think carry it, but I don't think they're going to carry the really nice, like millable ones that mill nicely.
Okay, next up. Seems like the other mill is being marketed as a mill especially for PCB milling, but would you say it's equally suited for milling small parts and other stuff out of aluminum, wood, etc.? I don't think it's marketed just for PCB milling, but where you're probably watching a lot of stuff is around Adafruit.
Yeah, we use it a lot for electronics. It's not what it's like the only thing it's good for, but I'll be honest, like the software is really good for that, and so it does one thing really, really well. It does other things well. I mean, like the people absolutely use it to machine wood and brass and jewelry and even, I think maybe even aluminum you can do if you set the feed rate properly and you're willing to go slow. I just don't have a use for that. I don't do robotics, I don't make jewelry. I did make Flux Pcbs once, but that's kind of the most interesting thing that we did. I think somebody at Adafruit made a bookmark. They like played with some brass, so it is possible. But yeah, you're seeing what I use it for, which is
Okay,
like PCB
next
design.
up. If you do a double-sided board, is there any kind of alignment steps to make sure the holes match up?
There's an alignment tool that comes with it, and I'll look it up on the machine. So fixture. So there's fixturing that you can get, and this is like a precision fixture with like little toes and stuff. But it also comes with fixture bars. I just don't use them because I just don't use them. But it comes with a bar that's like an L bracket, and if I had bolted that in place, I could have just put the PCB up to the corner, and then when you flip it around, you just put that same corner in, and then it'll automatically align for you. I don't do double-sided PCBs because all my testers are pretty simple, and honestly, something changed. Okay, it's time for the next step. I don't know what, but it took a break. Oh, it's doing the holes now. So it milled out all of the traces, And now
Yeah.
it's doing the holes. I don't think I want to pause it to clear it off and see the holes, but it's up to you. You want to do that? There's a risk of me damaging it.
What?
If I could pause it, open, and then brush it off so you can see the... Nah. We'll brush it off at the end.
Yeah. Next up, is it quiet? Yeah, it is. It actually
It's
is.
pretty quiet.
Yeah, this is an apartment. There's concrete walls, so it seems to be fine.
It's about... I would say it's about as loud as a quiet like a hand vac.
Yeah.
Like if you use a hand vacuum, it's about that loud.
Okay. Next up, how long do the tool bits last before needing to be replaced?
I say you can get away with maybe like 5 to 10. I mean, it depends on the complexity of the PCB, but PCBs like this, you could probably do like 5 to 10 before you want to change the bit. But the first 3 will look like really, really good, and then you just have to. What I do is I use like a scrubber, like you go to the store and you get those brass scrubbies for like scrubbing stainless pots and pans. You use one of those. Like they're not very popular anymore because everyone's got Teflon. But use that and you scrub it and you can clear off all the little flakes because you get little flakes.
Yeah. Next up, we'll do the second question second.
Okay.
So the first one is, other than not having to mess with chemicals and holes that get drilled, is there advantage of milling over etching for simple boards? And can you talk about Flux Pcbs?
You're definitely going to get much higher precision from a photoresist or even like a transfer system. Like I've done transfer for like the cell phone jammer. I did a toner transfer or photoresist. With photoresist, I've definitely gotten QFP like 10-10 rule boards. You can absolutely do it. You make 3 or 4 of them, and then only one of them really comes out just because you have to like avoid bubbles. But with photoresist, with like a UV photoresist and photosensitive PCBs, you are going to get like really, really awesome PCBs. But you can do double-sided too if you drill some holes and then use those holes for alignment. But it's just messy. I mean, you just have to give these chemicals, and we use this at work. And I have Alicia who helps build testers with me. I can send her the Eagle file and she can cut it out. There's no gloves, there's no like ferric chloride or cupric chloride. And for me, it's like I kind of prefer having the Othermill, but if I had to if it was just me at home, just like for fun designing PCBs, I do what I've always done, which is photo etching. It's really fast. You still have to drill the holes, but then I just got a little Dremel and you just drill the holes out, and it was always fine. And you get like much better precision. But you got a vat of chemicals in your house. And you have to change the chemicals, and you have to like get the heater, and it's a bit of an ordeal. Okay, drilling these holes. All right, well, 15 minutes in, but 20 minutes to go. Let me take this opportunity to clean around my desk a little bit. Very zen. Okay, taking a break. Now it's going to do the outline.
Okay, let's see. What RPM is the other mill and is adjustable? That one you might want to look at the other mill site.
Yeah, it.
Do you want me to? I think I'm gonna zoom out or something.
There is. It can tell you. I just don't like. And once it's running, it's tougher. But you can. It definitely does change the RPM. You can adjust it slightly, depending on the machine, and you set it up with the material. So right now it's set up for single side FR4, but depending on the material, you can customize the feed rate, the speed, like how much material you want to take off at a time. Like all of it is adjustable, just not while it's running.
Yeah. Okay, what kind of failures do the mills have? Like, can it break a drill bit or get out of alignment with the surface being milled?
Usually it doesn't get out of alignment, that's rare, but it definitely can break a drill bit or a mill bit. Basically just keep your mill bits very short and use the largest one you can get away with. And don't, basically that's why you would be feeding slower than you might, like, you know what I mean? Like as you increase the feed rate and the RPM, or lower the RPM, depending, it can cause drill breakage more. But as it's done right now, usually we don't break the bits so much. These days, it's mostly just the bits get a little dull.
Someone wants to know what kind of built-in features does the other mill software have? Does the dual toolpath generation for you? Is it necessary to use other software like that for Fusion 360?
I don't know whether it has. I think it has some integration with Fusion 360. I don't know because I've never used Fusion 360, but it definitely does all the planning for you, like the toolpath planning. I just loaded in this EagleCAD file, and it automatically generates all the toolpaths for you. Bleep.
Okay, next up, what process do they use to mass produce PCBs? So that's a chemical.
Yeah, it's definitely photoresist with just like very big equipment and very good alignment techniques. They can they basically take the bare double-sided PCB, they drill all the holes, and then they line up the photoresist, and they attach photoresist on top, mask it, with big UV lamps, and then they have like automated like dippers that take it through like a 5-part PCB etching solution, and they do both sides at the same time, and then they electroplate it. So it's a complicated process, especially electroplating, to get the through-hole vias and the through-hole holes. It's awesome, but yeah, it's like something you really don't want to do at home if you can avoid it.
Okay, is there a limit of the speed bit temperature or material toughness?
Yes, you have to have the feed speed and the RPMs based on the material. And like there's like Machinery's handbook and other books have information about like what speeds you can run with what, like how wide the bit is, you know, because tells you the speed of the outer edge. And then like this helps you calculate a little bit, but like if you're using a totally new material that other plant doesn't know about, you'll have to enter that in as a new material type and like give it all the specs.
Yeah, next up, does the software accept G-code? And if it does, that means that it would accept Fusion CAM outputs?
I think you can. Google for this G-code. I mean, I think if you open the debug console, you can enter in G-code. They have a little tutorial telling you about what all the G commands are and what what the units are and what they do. So, and then you can load up a script file and just paste in G-code. But like that's where you're kind of on your own if you end up making a mistake and just like slamming the tool into the spoiler board. That's kind of part of the joy of G-code, I guess. Maybe there's some basic safety built in, but you can set the spindle on to 16,500 RPM and like try to go through steel, and it's not going to work, but you can try.
Okay. How do they make multi-layer PCBs? So flip it over.
With 2-layer, like in general, or with this?
I guess on this one.
With this one, you use an alignment L that comes with it that I don't use because I don't use double-sided. You cut one out and then you flip it over so it uses that same corner, and it will automatically calculate and do the double-sided PCB for you. It works on Macs. Windows, they don't have it yet. They're going to maybe add double-sided support soon. Spending all of its time just like etching the outside. I'm kind of surprised. I think that the software at work, we set it up so it doesn't spend nearly as long etching the outer edge. Oh my God, it's going to do like 8,000 paths. Do you want to just like stop it now and I can take it out? Like I can just break it apart. I don't need to cut it.
What's the question?
It's going to spend like 10 more minutes cutting the outline, and I don't know exactly why, but it's going to do so many paths. I don't need to do I'll just break it off the PCB. Let me just pause now.
Sure, I mean.
Okay. So, yeah, spindle goes off, and then it raises up, and then I'm going to tell it to rapid to loading, because the cutting of the outline is the last part. So
okay.
if it's just like cutting the outline, I'm gonna.
Where are you going to show this off with the camera over here?
Yeah, I'm just going to. Can I pull this back?
Yeah, sure. Let me go to another camera angle here.
Is that okay?
Yeah, that's fine.
Okay, so remove the protector. And so this is the PCB over here. And I don't have a brush, so I'll brush it off with my hand. So I'll get a little vacuum and I'll vacuum this up. But this is the PCB. And I'm just going to clear off all this dust. So this is dust from the paper phenolic that was milled. And then, so I want to remove this, and at work I have a spatula. but here I don't. So you just kind of pry it off carefully so you don't crack the PCB. Whoa. And then there it is. That's the circuit board. Ooh, nice. So then you can see the holes. They're not cut all the way out. So like you can see that they're not, it's not like 100% all the way through. And that's on purpose because if it did, it could hit the bed. So I didn't let it cut all the way. I just cracked it off instead because I'm like, I don't want to wait 15 more turns. But that's it. That's the finished PCB. So the next step is, I like to poke the holes out with just like a pair of tweezers. So, like now the holes are all the way out. And you just clear out all the holes. And then you can put pogo pins in or standoffs or whatever. That's pretty much it. But the holes are aligned. You just need to kind of like pop out the little bit of skin that's left over. And yeah, this is a really nice cut PCB, pretty much ready to go as is. And these work well, but usually what I do is after I've run the PCB for a bit, like as a tester, and I know it's a good design, I do usually get a final PCB made just because you'll have a double-sided circuit board and it'll be nice and won't oxidize. This is one of the things, it is copper, it will eventually oxidize. It won't get damaged, but like these go through a lot of mechanical strain. So I prefer, once I feel like the design is pretty solid, I will move it to a finished PCB. And then I usually just toss this part because I'm not going to use it anymore. If you were making like small circuit boards, you could recycle it, but I'm not going to. Okay. And that's a finished PCB. Yay!
Okay.
Let me toss this. Okay. And then, you just have to clean off the machine, but here you go. Ooh, nice. So, I think without the outline, for some reason, it's like, I'm going to cut the outline 5,000 times. So it's like 20 minutes, basically, to cut the PCB and drill the holes. You can basically do this while you're designing another circuit board or writing code or something. You just have it running in the background and it'll mill out a PCB for you. And you can, if you don't mind using a smaller drill, using a smaller end mill, you can do as little as 10 mil rule. I do 24 mil because again, I'm whatever. I just wanted to, basic tester design, and I don't want to spend a lot. It takes longer, the smaller the end mill, the more precision. So that would take a couple hours, whereas this is 20 minutes. It's kind of exactly the right amount of time.
Yeah.
Yes. Sweet.
Okay, you did it.
That's it. That's the show.
All right, that's Disc of Lady 8. As always, Disc of Lady 8 is supported by you, the viewers. If you want to see more amazing content like this online, which so far I don't believe there's ever been a live broadcast of milling on the internet like this before. If you want to see more things like this is pretty advanced. We have multiple cameras, multiple networks. We're in VR. Nothing's like this, so please
Milling
buy
machines,
some electronics.
multiple lights.
Yeah, please buy some electronics.
Okay.
And that helps us pay the bills here and more.
Okay, maybe tomorrow for the show I will put this together and I'll write the code for it to show how we write the code for a simple tester. I think you can do that in 30 minutes each, so that's probably a good show.
We'll have some Disc Lady this week. We have Ask an Engineer, Show and Tell, 3D Hangouts.
We had a 3D stream this morning.
We had a 3D stream earlier today. There was Layer by Layer with Noe. And we have a bunch of stuff going on Instagram. And right now, we have hugvr.com/Adafruit, and you can see this whole setup.
It's crazy!
And then also on Twitter, you can see some of the 360 photos that I took during this broadcast. And on top of that, thank you everyone.
We put a cat in a box.
Well, we've done that. But thank you everyone who follows us on Twitter. We hit 100,000
Yay!
friends.
Aww.
Yeah, so that was neat. For an electronics company, that's pretty rare.
That's pretty cool.
100,000 people, and it's
That's
a lot.
pretty cool.
A lot of it's because we have cool content.
Okay, well, thank you, everybody.
Yep.
We'll see you in the rest of the week. We'll be doing tons of broadcasts and do things and post your projects and all that good stuff.
All right.
We'll be doing more milling maybe.
See you soon.
Later.